do an example using a gradient curve to come up with a name for a coarse soil, and this of course is under the Unified Soil Classification System. So as always, I've prepared an example with particle size against percents finer, and what we're going to do is we're going to graph this on a soil gradient curve. So I've done this example already. Once again, it's very simple to graph. You just graph the corresponding points and you join them all up. So this would be our gradient curve for this example. Now the first thing we need to do on our flowchart is determine the amount passing through 0.075 millimeters. So we can see this from our table. If we go to 0.075, 4% has passed through. Okay, if 4% has passed through 0.075, that means 96% has been retained above 0.075 millimeters. So that means that 96% of our sample is greater than 0.075 millimeters, which tells us we're dealing with a coarse material because the majority has coarse-grained particles. So we determined it's coarse, so we come down this branch. Now we need to work out whether the amount retained, so that 96% which is being retained, is the majority of that sand or is the majority of that gravel. So we come to our gradient curve, and what we can do is we can highlight the spectrum of sand and the spectrum of gravel. So sand starts at 0.06 to 2 millimeters, so we can highlight this section of our graph up to 2 millimeters, which is there. Okay, and we can highlight the section of gravel, which is just that section there. It ranges from 2 to 60, but we've only got up to 6 millimeters, so it's just that section there. So you can see that the overwhelming majority of what has been retained above 0.075 is sand, right? It's this branch here, which is sand. So we can say that our next point we go to is the sand branch, which means we pick up the letter S. So you can see that our final answer starts with an S. Okay, there's all these answers, and we have picked up the letter S. If it was a gravel, our answer would start with a G. Okay, so we've picked up an S, so that's the first letter we're going to start with. The next thing we need to determine is the percents less than 0.075 millimeters. So this is the percent fines. Do we have less than 5% fines, greater than 12% fines, or between 5 and 12% fines? So we can see this from our table that 4% has passed through 0.075 millimeters. So 4% is at 0.075 millimeters, and 4% is less than 5%. So this is less than 5%, which means we're coming down this branch here. So now we need to pick up our second letter. So it's going to be, our soil is going to be an SW or an SP. So we need to work out whether it's a W or a P. So we need to work out the C subscript U term and C subscript C term we defined in the previous video. So we know C subscript U is D subscript 60 on D subscript 10, and C subscript C is D30 squared on top of D60 by D10. And all those values was when we come to our flowchart, and we come to our gradient curve, and we come across to 60%, so D60 would be this value here. So we come to 60, we hit across, we come to the point there on our curve, and we shoot down, and we get a value around there. So this is D60, and it equals around 0.9 millimeters. Okay, so D60 is 0.9 millimeters. If we were to do D30, so we also need D30, so we come to 30% on our curve, we come and hit across, and we would get around there. So that is D30, and it's around 0.21. Remembering this is log scale, so 0.21. So D30 is 0.21 millimeters, and finally D10, we would find it the exact same way. Would come across from 10%, see where it hits our curve, come down, it roughly hits it at 0.1 millimeters. So D10 is 0.1 millimeters. Okay, so now we can work out the C subscript U and C subscript C term. So C subscript U is equal to D60 on D10, so that would be 0.9 on 0.1, D10 was 0.1, and we'd work this out to be 9. C subscript C is equal to D30 squared, so 0.21 squared, on top of D60, which is 0.9, by D10, which is 0.1. And this will equal 0.49. So we're now going to use these two values in our flowchart. So we can see, to come down this branch, both these conditions have to be met. CU has to be greater than 6, and CC has to be between 1 and 3. So CU greater than 6, it's 9. Yes, it's greater than 6. CC is 0.49, which is not between 1 and 3. So this condition isn't met, which means that we have to go down this branch. So to come down this branch, both conditions have to be met. Therefore, because this CC term wasn't met, we're coming down this branch, the else branch. So we've picked up the letter P and we're done. We can define our soil as SP, and that is our final answer. We've successfully defined our soil as an SP, which is a poorly sorted sand. Okay, anyway guys, just to quickly revise, we determined that it was coarse. We then saw that the majority of that was a sand. We then had to look at the percents finer. We saw that it was less than 5%, and then we had to look at the CU and CC term to see whether both those conditions were met, and we saw that it wasn't, so we got a P. We got a final answer of SP. Just a quick note, for the gravel, it's going to be a very similar process. The only difference is that CU is now greater than 4, and CC is still between 1 and 3. So CU is just changed to 4, where that was 6. But the flow would be the exact same. You would just pick up a G. Anyway guys, hope that helps.